trying to eyeball those measurements and then verify them with a tape measure, they found that this was on the order of 50 times faster than the same kind of record drawing production that they had done on previous projects. So it is using a SLAM-based system. All the localization and positional tracking is done in real time, all by ARKit. Got really deep into geodesy and converting ground to grid coordinates, all that kind of stuff. Doing a lot of cut and fill analysis, everything there. I love to nerd out on this tech. Point-to-point measurements for scenes of up to about 1,000 square feet are generally accurate to within plus or minus an inch. The longer you go, the higher the likelihood you're going to have some drift. But doing that cloud-to-cloud comparison, they found that the SiteScape cloud deviated from the Faro cloud. 90% of the points were within 5 centimeters. So yeah, welcome back. Really glad to be here. I'm Andy Putch, founder and CEO of SiteScape. I'm really excited to share a bit about mobile 3D scanning with the latest iPads and iPhones and how this is already having an impact on AEC. So for myself, a quick intro. Before SiteScape, I was an early hire at Drone Deploy. So I've been in the kind of reality capture, and especially part of my focus area there was on construction, job site monitoring, doing a lot of cut and fill analysis, everything there. So got really deep into geodesy and converting, ground to grid coordinates, all that kind of stuff. So I love to nerd out on this tech, but also spent a lot of time working with a lot of the VDC and AEC teams that were our customers there, and there was this constant ask that we love what drone-based mapping can do for being able to understand the whole of the job site, all the outdoors, the topology. But there weren't as many great ways to capture conditions in indoor environments. So that was always something that we actually tried a couple of experiments at Drone Deploy to see how we could expand into this space, extend these workflows to cover that. But we weren't able to really find something that fit the simplicity and ease of use that we were looking for. So when Apple put out the iPad Pro with LiDAR, like I imagine a lot of folks here were very piqued and interested in, what does this really mean? Is this actually LiDAR? And could this be a potential solution for that ask that we were getting so much from our customers there? So my real focus with this presentation is to give you a sense of where this tech is appropriate, the types of use cases, the limitations, and then also where it's not, where you shouldn't be trying to do too much too early, basically. So is there really LiDAR on these devices? And yes, it is a solid state direct time of flight LiDAR system. So all that means is that there are no moving parts. It's an array of lasers that shoots out in a pulse and then measures the time that it takes for that light to return. So there's some basic specs. It is quite low resolution. It's 256 by 192 pixels, or about 5/100ths of a megapixel. So we're starting with not even iPhone 1 camera resolution. We're way back in the Nokias. And the range is also quite limited. It's going up to about 15 feet, 5 meters, but the sweet spot we found is really kind of in the 3 feet to 12 feet range. You can get in a little bit closer, you can get in a little bit farther, but that's kind of the sweet spot there. So it is using a SLAM-based system. All the localization and positional tracking is done in real time, all by ARKit. For the various scanning apps, some will have loop closure and other things to kind of correct that, the raw SLAM calculation that Apple's doing. But for the most part, what makes a lot of this possible is Apple is doing a lot of the heavy lifting for their base, AR system. And then we'll dive deeper into accuracy, but if I had to give you one reference point to latch onto, point-to-point measurements for scenes of up to about 1,000 square feet are generally accurate to within plus or minus an inch. But we'll talk about what that exactly means. So where does this kind of fit in the landscape of existing reality capture solutions? To vastly oversimplify this, the 3 big buckets in my mind are photogrammetry, tripod-based scanners, and mobile scanners. And each one, I would say, terrestrial laser scanners, you're going for uncompromised accuracy. Mobile scanning, there's a huge speed element. And photogrammetry, there's a lot of flexibility. You can put it on a drone, you can put it on a 360 camera. But each of these have, their own kind of trade-offs and limitations, whether that's the time to capture, whether that's the cost of the hardware and software, how easy it is to handle and manipulate, tens to 100 gigabyte point cloud files. And there's also, trade-offs in ease of use and learning curve. But the biggest, factor that we saw and why we chose to pursue this was the alternative. If I'm someone who's not using 3D reality capture and I'm on site and I need to just get, a layout, I need to just get that floor plan, I need to get a rough sense of where everything is. Think an architect at the beginning of a renovation or retrofit project, even renovating your kitchen or your bathroom. The only alternative you have is sketching things out on paper, taking some laser disto measurements or using a tape measure, taking some photos, and then if you're going to CAD, going back into CAD and trying to take all those pieces and piece back together your scene. There is almost no middle ground. So there's this huge divide in between getting a millimeter accurate, highly detailed representation of the space and taking tens to hundreds of manual measurements in a really tedious and slow process. And that's exactly where we fit in. It's about being in the gap between those two. So SiteScape is basically a low cost. We only just launched our paid app, but we've been a free app. You can download it, capture spaces, export those points as a E57 or PLY file. We just added RCP exports. Very excited to get those, remove that step, get them straight into Revit and Autodesk. So we provide a whole solution with SiteScape Pro. You can sync your scans up to the cloud, where you can view them in a browser, share the link, leave comments, take measurements, or just export those scans. But it's a way to, an end-to-end solution where there's the capture side, managing all that data, and sharing it, throughout the project team. So the big thing that I really want to, get back to is the right types of applications. The big ones we highlight, and I'll go through these in some case studies, are modeling existing conditions, documenting, and resolving problems on site, and verifying as-builts. But even within those, there's kind of a subset that you need to really kind of focus on. And that's the biggest piece is we are kind of limited into how much can we capture in one go accurately. Because the big limitation, of every SLAM system is you build up drift, it accumulates over time. The longer you go, the higher the likelihood you're going to have some drift that's causing and degrading the overall accuracy of your scene. So being able to go and just capture, one room in its entirety, or the elevation for a wall and the MEP inside that wall, and kind of breaking your space up into sections, that's going to be the biggest piece there. If you're looking to scan an entire building and you're trying to go room by room with the iPad and capture all of that, you're going to be much better off with a system like Naviz. And if you have very fine survey tolerances, or you're doing offsite fabrication, you're going to want to use a Faro or Leica, or hire someone like our lovely host today, like Nexus 3D, to go and do that capture for you to make sure that you're getting the data and the accuracy that you need. So it's in no way anywhere an alternative or a replacement for traditional laser scanning. It can't compete in terms of the resolution and accuracy and precision. It's something that fits in an entirely different category. So that category is really just all the instances where you good enough is good enough. It's where you just need to get a rough sense of the space, and you can have some like I was saying, that plus or minus an inch. You can get measurements that are going to be approaching where you could start to make some more detailed design decisions or troubleshooting how things are fitting and things like that. So yeah, to move that on. But let's dig deeper into that kind of question of accuracy. So I'll cite two studies. The first is one coming out of the Laboratory for Geomatics and Cultural Heritage that was published in ISPRS. And so what they did is they used a Faro Focus and then SiteScape on the iPad in a set scene with a bunch of ground control points and then control points, and they scanned it time and time again to get a data set, and then did first a kind of direct cloud a comparison to those control points, and then where the position, where those, the points that those represented in the point cloud, where the two said they were and what the difference was. So they found that for those control points, the average error was around 2 centimeters, and the standard deviation was about 1 centimeter. So just those kind of point-to-point ones, they found it to be quite close. But then doing a iterative closest point analysis, basically doing an optimization of the Faro and the SiteScape scan to line them up and get them as close as possible. Also, they found that the Faro data for that control point test was about 10 times more accurate than SiteScape, so no surprises there. But doing that cloud-to-cloud comparison, they found that the SiteScape cloud deviated from the Faro cloud such that 90% of the points were within 5 centimeters of that Faro cloud. So it's that kind of, 5 centimeters is around 2 inches or so. So it's something where if you look at the kind of distribution there, you're getting a lot of accuracy and measurements that are going to be accurate there, but there is that chance that you're going to have that one piece of data that's not as tight as you need it, and that's the key thing to kind of be aware of there. So another study was something we did internally because it was a big question in my mind. I set up my own kind of experiment. We laid out 6 control lengths, basically marked them up on the floor, on the walls. They were in all X, Y, and Z, and then measured those with a good old fashioned tape measure. So we got these reference control lengths and then scanned the scene 9 times with SiteScape, brought all of those into Cloud Compare, and then measured each of those known lengths to see how they varied against the tape measure. So we found that the average error was about 0.7 inches, and 90% of the measurements had an error of under 2 inches, so also 5 centimeters. So the data kind of shows that the rough, how the error distribution and what you can get out of these data sets is quite close. But it's that level of, I like to say, don't expect anything less than that kind of plus or minus an inch. It's that kind of level, but know that in some instances, especially if you have shiny reflective surfaces, you're scanning larger areas, the chance that that error distribution is going to go up can increase. So it's something that if you really need to guarantee accuracy, you're going to need to go for other methods. But when does that? There we go. What are some of the cases that folks are using this today here? So the first one is really at the beginning of any design build project. So we worked with an architect out in the UK, their firm Namni Plans, and so they were jumped on this, really excited, deployed it on every single one of their projects, and they were going in doing a lot of renovations for single family and multifamily homes in the UK, and for them being able to just go and do a quick scan of those existing conditions as the basis for their design. Again, their previous workflow was sketching things out on paper and then translating all of that into ArchiCAD. They were able to just have this 3D point cloud and use it as almost like 3D tracing paper. You're taking that rough scan, starting to line up the walls, the cabinets, the ledges, everything else, and get all of that into your design space so that they could say, all right, here's what's going to stay, here are the walls we're going to knock down, here are how things are going to shift around. And we've gotten, our biggest user base is actually by far architects doing this type of thing, just getting a sense of not only the floor plan, but like where was that outlet or that smoke detector, and being able to capture and understand the space in a very quick amount of time with more context than you could get for a photo, and having some of those dimensions and everything else there. Next, we just released a case study with Mirren Construction. It's a big contractor out in the Midwest. They were doing a similar industrial retrofit project, and going into this project, the team actually knew that the existing structures, particularly in the MEP, was underdocumented. They had some plans from the record, but they knew that there were going to be things that surprised them there. So their team and their subs all kind of designed to the best of their knowledge of, all right, here's how we're going to route the new components that we need to put in place. But when they got on site and did that demo, the demo work, they found that not only was there a large precast concrete beam going straight through the ceiling, there were also these a whole series of concrete T's that were completely undocumented there. And those are right orthogonal into the path of a good amount of ductwork, fire suppression, and other MEP systems that they were planning to start installing in the next 2 days. So by being able to go and do a quick capture to just show where those T's were, the rough sizes of them, and then from the field send those straight out to their back office, their modelers, but also all of their subs, they were able to give everyone this kind of coordinated view of, all right, what does the actual space look like, and start rerouting those pipes in order to accommodate for that roof structure. So it was something where, again, you're not cutting the pipes based off of the measurements of the model, but you're able to see where are things going to be tight, where are the major obstacles that we need to avoid, and be able to get a much better first pass at what is this MEP system going to look like in a very short amount of time. All right, my last and favorite use case here is at the end. So we start at the beginning, modeling those existing conditions, troubleshooting problems on site. The last one is just capturing as-built. Where did everything line up in the end? And so this case study was with a construction solutions firm up in Canada, Hollowbuck. So they were working on a project with the University of Alberta Pharmacy Dentistry School. And so it's a big pharmacy school. They have a lot of medical MEP. And this was a more extreme example, but quite illustrative. You can see they produced a record set of the blue being where the various components were designed. So the ducts you can see in the one in the top left corner are off by a foot or so. The pipes along the wall on the right-hand side are all in the correct place, and that was kind of verified by the scan. But those ducts are way off. And then in the second one, it's completely different duct geometry that was used. So we're kind of wondering what was really going on here. But it illustrates the fact that things will kind of vary, and it's almost trivially easy to look at that overlay and say, okay, here's where we're seeing deviations, versus trying to look at plans on one hand and being on the actual site on the other, and trying to say, is that shifted over? Trying to eyeball those measurements and then verify them with a tape measure. They found that this was on the order of 50 times faster than the same kind of record drawing production that they had done on previous projects. And so in the aggregate time savings added up to a $50,000 cost savings for the team and the subcontractors. So it's this one's probably my favorite here. Just being able to, when you don't need to have that exact estimate or document of where that pipe was, because you're not you're just taking that record drawing. At least you know whether the pipe was there or not, and where it was with respect to the components around it. It's a much better reference than just taking a couple photos or trying to go through the process of manually updating that record drawing. So that's something that they're continuing to use on other projects. So each of these, there are a lot of various kind of applications of where you can get a lot and you can make a massive improvement over the previous workflows, but it's not something that really compares to when you need a high-end terrestrial scanner. The analogy I like to think of is it's like using first-generation iPhone photo versus a CineCam or a DSLR. There are always going to be instances where you need professional equipment operated by professionals, but there are a lot of other instances where you can just snap a photo on site and be able to solve a lot of problems by sending that out to relevant stakeholders and everything else. So that's my presentation. I hope that was helpful, and happy to answer.